To math learning groups again. Right, today we're going to look at another kind of speed problem. For speed problems, there are many scenarios, many kinds of how they move. All right, different people move differently. Right, in the story. So there can be all kinds of scenarios. So it's almost impossible to tell you all the scenarios. So we're going to look at this question, but the matter is still the same. No matter what speed problems you see, the method that we're going to use is always the same. You just have to learn how to draw out the problem and then just go through the process of drawing the model, and from there then you have a high chance to get the answer, right? Otherwise you find that it's very abstract if you don't have any visual visual representation. So the model is like a visual representation for you to break down the problem so they can see more clearly. So let's look at this question and let's see how do we draw out this problem. Now you can see that Peter and City took part in a race, okay, in the race. And when Peter had completed the race in 20 minutes, City had only run 5/8 of the distance. So who is faster in this question? That's why you always need to ask yourself when you see a speed problem. You need to think about who is faster, which is Peter, and City is slower because City hasn't completed the race yet. And Peter's speed was 60 meters per minute faster than City. So we have seen this already. What does that mean? What do you mean by 60 meters per minute faster? It means that in 1 minute, Peter traveled 60 meters more than City, and that's why Peter is faster. And what was the distance of the race? Well, some of you might be able to solve it without any model, but others may not be able to solve it because it's looked very hard. Alright, it seems to be quite hard to even know where to start. So I will advise you, like as what we always do, is to draw the model. So there is a distance race or distance line, and this is the start of the race and that's the end of the race. So this is called a distance line. And then there's a dotted line to show where they start. So Peter and then you have City. So you have two person, right? And they are at the same point. And when Peter had completed the race, so you have to draw Peter all the way to the end. And there's also a dotted line to show what? To show where Peter has arrived. And City had only run 5/8 of the distance. So City did not complete the race. She's somewhere. And we have a dotted line to also show where she is. So the dotted line tells you where they are, and it also tells you how many parts of the journey, right? For example, you can see that City still got some more distance to travel. So that is an invisible part. So what I will usually do is eventually City is going to complete the race eventually, right? Because it's a race. She cannot stop halfway, right? So she will eventually have to complete the race. And that's where I use a invisible arrow. So this is like a invisible arrow that tells you that City will eventually continue to run and complete the race. So City got two parts. Okay, so that's the model. So what do we do next? Well, you need to recognize how many parts of the journey. Peter has one big part, so you have one family for him. City has the first part, which is what she has already completed, and then there's a second part, which is what she will complete, right? What she will run. All right, she'll be running the last part of the race. So this is the second part for City. Then you ask Mr. Ong, is it okay if I don't have this second part? Well, it's okay if you don't have this second part. But you might find it a little harder to continue solving later. So your model tries to be as clear. When you draw your model, you try to be as clear and have as many things inside so that there's a higher chance to work out the answer later. Alright, so your model is almost completed. So what is the next thing that we do is to plug the numbers and put inside. So when Peter had completed the race in 20 minutes, so because they started at the same time, right? So where was City after 20 minutes? She is somewhere here, right? After 20 minutes. So the time taken for City is also 20 minutes, which is until the black arrowhead. Okay, so you will need to know where to put the numbers. Because if there are numbers that you never put inside, then you find that you will get stuck. So you will have to understand where to put your numbers so that your model becomes very clear later. Alright, and then City had only run 5/8 of the distance. Do I cut the distance into 8 parts? Again, if you go back to my earlier lesson, we don't cut the model into 8 parts. We just put down the fraction inside the model. That is 5 units. Siti has run 5 units, and she has another 3 more units to complete. And Peter has completed the whole race, which is 8 units, one whole. Right, so the entire race is 8 over 8. So this is what you do when you see fractions, right? You put it into the model, don't have to cut it into many parts. Do I put the 60 meter per minute faster into the model? No, we can't, because that's not the speed of Peter. This is not Peter's speed, so you can't put inside. So we just leave it out. So what was the distance for the race? And that's your question mark. Or you can find the distance of question mark here on top, same. Alright, that's the distance line. And your model is done. So if you can draw a good model, something like this, then there's a higher chance that you can solve it. So you look at the model, and what do? Is there something we can work out? Then you will need to understand the concept of what do you mean by 60 meters per minute faster. It means that in 1 minute, Peter traveled 60 meters more. So you need to understand the concept here. 60 meters per minute faster means that in 1 minute you travel 60 meters more. Then you look at the time taken for Peter to travel. Peter took 20 minutes to complete the race. So that will be how many meters more than Siti? That will be 60 times 20, which is 1,200 meters more than Siti. So that tells you that Peter is ahead of Siti by 1,200 meters. And isn't that over here? So Peter is far ahead of Siti, and Siti is behind him. And how many more meters did Peter travel than Siti? 1,200 meters, which is 3 units. Right? So 3 units is 1,200 meters. So what's the distance of the race? Which is 8 over 8, or 8 units. Then what do? Then you just take 1,200 divided by 3 to get 400, which is 1 unit, and then 400 times 8, that will be the distance of the race, 3,200 meters. So the distance of the race is 3,200 meters, and that's how you solve it, by the model. And of course, to understand, you need to understand the concept on what do you mean by 60 meter per minute faster. So if you understand that concept, then that's how you solve it. And do I need to find the rest of the missing numbers? There is no need, because you got the answer already, right? So once again, you can see that it's all about the speed model. Okay, the speed model that we can use to solve all kinds of problems. But you will need to develop the ability. You will need to be able to develop, you need to practice, all right, practice on how to draw the model. Otherwise, you find that it's going to be very hard to draw out your model, right? Especially your bar model, your comparison model, bar model, right? Some students, until now, they have difficulty drawing the problem using bar model, and as a result, what happened is they can't use their model to solve. Their model is too simple, right? You don't need a complicated drawing. You just need to know how to draw out the sentence by sentence, and what you draw is what you're going to use to get the answer. All right. Okay, so hopefully at the end of all these speed lessons, you will have a better understanding on what is speed and how to find speed, distance, and time, and how to draw the model. And for the coming few lessons, I may be talking about speed lessons again, but we will now also move to how to avoid careless mistakes. All right. So if you go to my YouTube channel, you will find that there are some lesson videos on how to avoid careless mistakes. So we are going to talk about that again, because there are so many kinds of careless mistakes that students can make, and how to avoid careless mistake. Many parents have asked me this question. One of the ways to avoid careless mistake is to know what they are. All right, to know what they are, and then once you know what they are, and then you just don't repeat those mistakes, because you know what they are, so you are aware and you do something else, right, to get the answer, so that you don't make the same mistakes, right? So we will talk about that in our up and coming lessons, but we will also continue to talk about speed lessons. All right, I may choose some speed problems, which is a little harder, and then using the model, and I will show you how to use a speed model to solve those harder questions. So stay tuned, right? Stay tuned to our coming up lessons, and then hopefully, as you keep watching the lessons, you begin to understand how to solve. All right, so see you in our next lesson.